Hi, in this video, I'm going to walk you through a performance test when we integrate Spring Boot application with Lite4j middleware handlers. We got a lot of requests from our customers ask if we can integrate the Lite4j middleware handler to address cross-cutting concerns for Spring Boot applications because they have a lot of applications built on top of Spring Boot already. And we spent some time trying to figure out how we can inject Lite4j handlers into the Undertow HTTP core in a Spring Boot application. So during this investigation, we built this sample application, and we did a performance test. In the same Spring Boot application, we have two different endpoints, implement using Spring Boot and Lite4j separately. So the entire application or the article is you can find from the Net1T document site in the benchmark Spring Boot section. This is the entire test we've done. It's all documented. So now I'm gonna walk through using the entire process in the video, so that if you don't want to try this on your local, you can watch the video. Let's first walk through the process. We're first using this Spring initializer to generate a project, and after that we made some modifications. Let's go through the source code so we can see what's the source code look like. So this is the source code we right after we generate the project, we made some modification to the project. First, we switched the Tomcat. We switched the Tomcat embedded server to Undertow. So here we add this exclusion section in the Spring Boot starter vibe, and we add this new dependency called the Tomcat. Spring Boot starter Undertow. That's what I've been changed in the pom.xml. And the next we've done is we add this section, this bean, into the demo application. Basically, we are defining a new embedded servlet web factory. Within this factory, we have injected a customizer. This customizer passing to the deployment, passing a deployment info. Within this customizer, we just add initial handler chain wrapper with the existing handler, handle the root prefix for the path, and using this test handler to handle /Lite4j. The test handler just implemented Undertow handler, which is exactly the same like Lite4j handlers. So we just return OK, nothing else. This is a normal main method for the normal Spring Boot application. We have this path Lite4j for the Lite4j handler, and then we implement a new controller for Spring Boot. This is the one. So this is a REST handler, and we have mapping is /Spring Boot. It's the same returned OK for this controller. So this is the same implementation with the same result. Similar implementation with the same result is using the Spring Boot as a path. And you can see Lite4j using /Lite4j as the path. So now let's test the performance. This is like two different implementations for two different paths in the same Spring Boot application. Now let's do some performance tests to see what's the difference between those two different implementations. We are using WRK for performance. So first, let's start the server. Yeah, so we are in the folder. So I'm gonna start a server just using java-jar target performance application. Okay, now the server is started. I'm gonna open another window to run the performance test. We are using WRK for performance test. So first, let's hit the Spring Boot endpoint. With WRK. So this is basically we start WRK with 8 threads, 128 concurrent users. Run this for 30 seconds. It's using a pipeline.lua to generate more load to this localhost 8080, and the path is /Spring Boot. We basically interested in the latency numbers. So when we get the result, we can see the latency number. So let's run this for 30 seconds. My test computer got AMD 2700X CPU with 80 cores and with 32 gig memory. Okay, now we got the result back. So apparently we have a latency is 31 milliseconds on average, and we have about 200k requests per second, and the entire transfer data is 23 meg during this 30 second period. So now let's use the same command and change to the Left4j path. We just need to change Spring Boot to Left4j. And run the same test again for the same 30 seconds. Now I can hear my CPU fan is running very, very loud. Okay, so now we have the result back. So we have average latency is 1 millisecond compared with 31 milliseconds with Spring Boot. And for our throughput is about 4.6 million requests per second. And we handle the transfer rate is about 440 meg compared with 28 meg throughput. This is the entire data transferred over the network. So you can see the performance is a big difference in terms of performance between Left4j and the Spring Boot implementation. We don't know what is going on. We are injecting the Left4j handlers at a very low level. However, there's still too much overhead for the handlers. If we test Left4j application alone, without Spring Boot, basically a Left4j service, we can reach about 7 million requests per second. So right now we are about like 2/3 of the throughput if we run the Left4j handler within the Spring Boot application. I think there's still somewhere in the Spring Boot still adding some overhead. But from this number, you can see that there is a big difference between the Spring Boot controller and the Left4j handlers, and this further convinces us, okay, we should implement the integration for Spring Boot, so that for users they can leverage the Left4j middleware handlers to address core coding concerns, instead using the Spring itself, because Spring framework adds a lot of overhead, especially when you are working on microservices. The throughput and the latency are very important because you have multiple services interact together. We have tutorials. We have a project called Spring Boot. Basically called Light Spring Boot. And within this project, we have a Spring Servlet implemented already, so that you can use this to inject Left4j handlers into your Spring Boot application. Also, we have some documentation and tutorials to show you how to use that. When I have time, I'll probably create some videos to walk through the tutorial, so the user can easily leverage Left4j handlers. That's it. Thanks. Bye.